And welcome to 1.1b, make qualitative non-mathematical predictions about the relationship between variables. Once again, I'll just remind you that the place that we're at here, I'm going to pick a new color, is we're at that outcome right there. So back to the right spot. So I guess first of all, what is that word qualitative mean? So some of you may realize this. Qualitative is a fancy word that just means we're talking about words, and often it's contrasted with the word quantitative. So something could be qualitative, which means a prediction, in this case in words, or it could be quantitative, which would mean involving numbers. So in the title, when I'm saying make qualitative non-mathematical, mathematical clearly means quantitative in using numbers. So in our initial lab using the pendulum, what are the possible outcomes? What are kind of predictions that we should be thinking about? Well, we're changing three things, aren't we? We're changing amplitude, and we're wondering how this may have an effect on period. We're changing mass, and we're changing length. So these are the outcomes that we're going to sort of think about here. So maybe the first one would be, what if I increase increase the amplitude was the first one we're looking at. Increase amplitude. If I could spell, maybe I'll fix that a little bit. Amplitude. How will that affect period? So increase in amplitude, how about will result, do I have space here? Will result in blank in period. So, three different possibilities, I guess. You could say an increase in period. What would that look like? Take a longer period of time to get back and forth. A decrease in period, which means it would do the back and forth more quickly, or no change. So consider now what your answer is and put one in there. Make a prediction. The second one would be an increase. You know what, I'm just going to pause it and write it out. Okay, so I wrote out for the second one, an increase in mass will result in blank in period. And again, I invite you to either write increase, decrease, or no change according to what your prediction is. The last one, increase in, I'm just going to give you a chance to recall what the third independent variable was that we were changing, and can you finish number 3 on your own? So I'm just going to go on to the next part here. Including an actual prediction really is optional when you think about what is in a formal lab. Really what I want you to do is to think about anticipate what possibilities will happen. So I don't have to say I predict that, because that's what you're doing in steps 1, 2, and 3. And the other thing is, I don't want you to think that somehow your lab turned out poorly if that you didn't predict correctly. The point is not to make a correct prediction. The point is to think about what your hidden biases are, and to make sure that you allow the results, the data, to speak for themselves. Don't worry about getting your prediction right. Worry about getting good data. Okay, let's move on. Oh, actually, should I put the answer for this one? Increase in the last one was length, wasn't it? Again, will result in blank in period. And I want you to have something written into each of those three. 1.1c. So just a quick one here. So this now we're at here, record the procedure used to gather data from the apparatus. So really, I'd like you to record this procedure after you finish the lab. And This is because I want you to feel free to sometimes adapt your procedure to making sure that you're getting good data. If you collect a couple sets of data and then you realize that there's a problem with what's going on, you may want to revise the way you've set things up. And don't throw away the data, but make a note of what you did and how you changed and why you changed it. The point is that sometimes the whole lab is kind of an ongoing procedure of learning as you go, and that's okay. We just want to be transparent with the whole thing. Rule of thumb about how to write up a lab is a reasonable, intelligent person who was not there should be able to figure out what was done by reading your procedure. And diagrams and a list of equipment are helpful. Be clear and concise. That means don't worry about writing too much. So perhaps for our example, I think what I did is I gave you guys a ring stand, so you can even draw sort of a picture of the ring stand, and there was a clamp, a little horizontal piece that was clamped onto there, and then from there you had a string that was tied to a hanging mass, right? Something like that. I'll pause and I'll write down a suggestion of what you could write. Okay, here's what I put as a hypothetical procedure. So this might not be the same as what you would be writing. I wrote a ring stand with a horizontal bar was set up using a clamp. So I guess the clamp would be like over there. The length of the pendulum was measured to the center of the mass. So if we were to measure length, it would, I guess, be from here to here. Not necessarily just the length of the string. Period was measured by timing 5 back and forths and dividing by 5. Some of you may choose to use 10. I added another thing in green saying we had to tighten the clamps to reduce wiggle. So perhaps you're setting this up and you had a couple of trials and you noticed that the whole thing was sort of shifting around. Some of you may actually find you want to put a couple books on the ring stand if you're using a particularly heavy mass because the whole thing looks kind of shaky, because you really want the pendulum to be stationary at this point here. So if there's anything that's moving around, you probably want to do what you can to make sure it stays still. Or perhaps you don't want to use the ring stand at all. Maybe you want to tie it to something on the ceiling, or maybe you want to tie it to something that you for sure know isn't going to move around. That's totally up to you. But if you do find you need to adjust your procedure a little bit, that's fine. Just write down what you're doing. Okay, I think that's all for this, and I'll see you in class.